In this lesson, we're going to look at the intersections of lines and parabolas. Now, just an example here of where this might appear in real life. Engineering and construction usually is started in a process on a computer where things are modelled. Now you can see a bridge construction here consists, something like the Golden Gate Bridge I suppose, consists of parabolic hanging wires, supporting wires, and then a road. So this would have to be modelled on a computer. In order to model these things in the computer and adjust them, it's much easier to create formulas for the lines and the parabolas. And obviously they intersect at some point. It would be good to know what points they intersect at, and in order to program these into a computer, you must know what the equations or the mathematical formulas are for them. So this is where it could be used in real life. In order to understand this next process, I'm going to do some basic logic calculations with you, so that hopefully if we do it simply, it makes more sense when we go into the algebra side of it. So I'll do two examples here. So let's say that a was equal to 8. Okay, so we can also say that a could be written as 2 plus 6. That seems fair enough, because 2 plus 6 makes 8. So the follow on from that is, we don't really need the a's. We could basically say that the red bit equals the red bit. We could say that 8 equals 2 plus 6. If a is equal to 8 and a is equal to 2 plus 6, that means 2 plus 6 is equal to 8. Now I know this seems quite obvious, but we can use this technique and this idea to do harder things. I'll do one more. So let's say b was equal to 11. We could also say that b is equal to 55 divided by 5. Now the logic from that suggests that 11 is equal to 55 divided by 5, if they come to the same thing. Okay, let's see where that could be used. So here's an example of lines intersecting parabolas. So here's the example. Find the coordinates of the 2 points P and Q where the parabola, the blue part, meets the line y equals negative x plus 3. Now just a couple of points to note. The parabola has a plus x squared, which means it goes down and then back up. It's got a minimum turning point. And the equation of the line's negative, so it's got a negative gradient and an intercept of 3. So the way to do this, it's kind of similar to what we did before. If y is equal to this part and y is also equal to this part, just like we did with a's and b's last time, then these highlighted parts must be equal to each other. And we call this idea y equals y. So you set the value of y to the other value of y, and this looks like this. So x squared minus 4x plus 5 is equal to minus x plus 3. Now I tend to always put the x squared on this side. You'll see why in a minute. It just makes it easier for me. It doesn't need to be that way, but I just like it. If you were trying to say, well, which one do I write first? Well, I always write the one with the x squared on this side. If they both had x squareds, then it wouldn't matter. I think you see that later on in the exercise. So the idea behind this is, if we can solve this to work out what x is, then we can get the x coordinate of the 2 points, and then we can use one of these equations, either or, to get the y value. So in order to solve this, what we want to do is get everything over to one side. So you want to add the x over, and you want to take away the 3. And you could write this like this, but you could actually do it very quickly, and you set it equal to 0. So I don't mind if you wanted to go straight into that. If you add the x, you'll get minus 3x, and if you take away the 3, you'll get down to 2. Now this is a quadratic equation that we've been solving in the last exercise, or the 2 exercises ago. So what you do, you factorise to solve it. So this is the idea. We get everything over to one side, set it equal to 0, and factorise. Now that's going to go into double brackets. 2 times 1 makes a 2, and a minus 2x and a minus 1x will give you the minus 3. You must be good at factorising to do this. So we've got two values that make this work. Either x equals 1 or x equals 2. So it's looking at that point, there's 1 something, and this point here is 2 something. In order to find what the y values are, you can either sub them both into here to get the y values, or here. I always pick the easiest one. It should come out to be exactly the same. So I'm going to sub these values into here to get my corresponding y value for each of them. So I'll put 1 in first, and then I'll put 2 in. So it's minus x plus 3. So when x is 1, y is equal to minus 1 plus 3. That's easy enough, that's 2. And when x is 2, we'll put it into the same one. It's minus 2 plus 3. So that's 1. So looking back at the diagram, if I'm looking for P, that looks like 1, 2. And if I'm looking for Q, it looks like 2, 1. So I'll just finish that off. P is 1, 2. Q is 2, 1. Okay, I'll do one more example. This time, if we look at it, find the coordinates of the 2 points P and Q, where the parabola y equals negative x squared, take away 4x, take away 4, and the line y equals x plus 2 meet. Again, looking at this, we've got a negative x squared, which is creating this maximum turning point on the parabola. We've got a positive gradient this time in the straight line, and an intercept of 2. Positive gradient, intercept of 2. Just understanding behind that diagram. Okay, this is slightly trickier with negative x squared. There's a wee trick we can do though to help us out. So again, start this way, let y equal y. So this part here is going to equal to this part here. Just like that. Okay, I'm going to take away the x to get minus 5, and I'm going to take away the 2 to get minus 6. So we always take over one side and let it equal 0 to solve a quadratic equation. Now, I never like factorising with a negative x squared. So what I'm going to do is, I'm going to times everything by negative 1. Basically change all the signs. So times by negative 1, times by negative 1, times by negative 1, and times 0 by negative 1, which just keeps a 0 over here. So that makes it much easier to deal with. So into double brackets, 2's and 3's this time, 2 times 3 makes 6, and you'll get a 2x and a 3x to give you the 5. So our x values, minus 2 or minus 3 to make 0. Again, similar to before, to get your y values, you can sub them into either. I would choose this, it's much easier to get a y value, but if you sub them in here, it should work out the same y value. But I'm going to put it into x plus 2. So we've got minus 2, so minus 2 plus 2 is 0, and then we've got minus 3, so minus 3 plus 2 is minus 1. Now just deciding which one's which, well, it looks like Q is the minus 2 one, so that'll be the minus 2, 0, and the other one's going to be P, minus 3, minus 1.